Thanksgiving. We're going to do a quick podcast to review for your test on Tuesday. So let's get started. Number one, use Newton's first law to explain why a heavy regulation football, heavy meaning it's got lots of mass, is less likely to be blown around in the wind after it's thrown than a lighter, less massive Nerf football. Newton's first law, you should be thinking the key term is inertia. And inertia is the resistance to change in motion. So a heavy football with lots of mass versus a Nerf football with less mass is going to be less, so the heavy football will be less likely to be blown because it needs a greater amount of wind to push it off its course. Okay, another way of saying that is the less mass means that an object's going to have less inertia and be more likely to be pushed off its course. Number two, use Newton's second law to explain why using a golf ball as your catapult projectile produces more force against the force plate than a ping pong ball. Same principle here, different law, more mass. So Newton's second law says the more mass you have, the more force you will produce. And it also says the more acceleration you have, the more force you will produce. So using a golf ball has more mass than using a ping pong ball. Number three, use Newton's third law to explain why you can throw a softball further on pavement with shoes on than on pavement with rollerblades on. Well, Newton's third law basically stated is that every action, for every force, there's an equal and opposite reaction, meaning a force in the equal and opposite direction, which basically is just saying forces act in pairs. If you are applying a force in one direction, you're always going to have a force going in the other direction. So, for instance, you're swimming. You're kicking the water when you're swimming. When you kick the water, you're being propelled forward, but you're also propelling the water backwards. There's a pair, there's a force pair. When you are catching a baseball, you are applying a force forward as the baseball hits you in the opposite direction. There's another set of another pair of forces. And when we're throwing a softball, you're going to have to push off your back foot to throw that ball effectively. And the reason that you can do that, if you have good shoes, is that you are using friction to kind of plant your foot and to push off that foot. Now, if you do that in rollerblades, because the rolling friction is significantly less, the rollerblades will not keep you from going backwards, and so that softball will push off. As you're pushing off the softball, it will push you backwards just a little bit. Question number 4 states, use all of Newton's laws to explain why a catapult with more mass was able to launch a projectile with more force than one with less. Using Newton's second and third law, we can really kind of connect those two laws to apply them to the entire mass of the catapult, because we know that the more mass we use, the more force we'll have to apply. But we also know that forces act in pairs. So when we launch a projectile with a large amount of force, that projectile is going to apply a force opposite in the direction it's going. That force is going to need to be kind of countered by another force based off of the catapult, based off the mass of the catapult. So the more mass of that catapult, we can just keep building that into more force of the projectile. So we're going to need more force, we're going to need more acceleration. Let's add one more thing to that, and that is the energy of either the rubber bands or if you have a counterweight. So the larger, the more mass that you have in your catapult, you'll be able to hold more energy and be able to hold up a larger counterweight or to hold more rubber bands. And that is the mass of the catapult will stabilize the mass or the amount of energy, and it will apply it to your projectile. Question 5. Describe the forces on a bowling ball that has been thrown and is rolling down a bowling lane at 3.6 meters per second. is the bowling ball accelerating. So let's describe these forces. First of all, we have the force of gravity. We also have the up force, which is being applied by the bowling lane, and we also have a frictional force, a resistance force that is going in the opposite direction of the bowling ball, in which the bowling ball is traveling. But there is no real force being applied to the direction of the bowling ball. So if the bowling ball is moving from right to left, you've thrown that bowling ball, it's already moving right to left, but there's no more force being applied after you've thrown it. So you've got three forces working on it. You've also had the momentum working from right to left. Is that bowling ball accelerating? Well, it's unbalanced forces. So you have frictional force acting in one direction, but no other force acting in the opposite direction. So there is a negative acceleration. Acceleration is going in the opposite direction of the velocity. What's the momentum of the ball if the mass is 4.2 kilograms? Well, it's going to be 3.6 meters per second times 4.2 kilograms, which is 15.1 kilograms times meters, and it's all divided by seconds. So, number 6, describe all the forces on a penny that is falling and traveling at terminal velocity. If the penny has a mass of 20 grams, determine the weight of the penny in newtons. Let's do that one first. 20 grams is 0.02 kilograms, and we would multiply that by 9.8 meters per second squared. And of course the answer is 0.196 newtons, and a newton, as you know, is equal to a kilogram times a meter divided by a second squared. So the forces on the penny that's falling, it's really just two forces. We've got the up force and we've got gravitational force. So gravity is what we just figured out. The up force is going to be the force of air resistance, and because it's at terminal velocity, meaning that there is no more acceleration, the net forces are equal to zero, meaning the force going up and the force going down balance each other out, which means we have 0.196 newtons going in the opposite direction up. That's the force of air resistance, and we can always figure out the force of air resistance based on if we know what if we're at terminal velocity.